Hey scholars, today you will learn about tectonic plates. By the end of this lesson, you should be able to know what is the tectonic plate theory. What are the three types of tectonic plate boundary? Before we begin, let's activate some prior knowledge. Pause this video right now and answer the following three questions. What are the layers of the Earth? The layers of the Earth are the inner core, the outer core, the mantle, and the crust. What are the two major divisions of the mantle? The mantle is a semi-solid layer subdivided into the upper mantle and the lower mantle. The lower mantle is called the mesosphere, and the upper mantle is divided into two major distinct subdivisions, the asthenosphere and the lithosphere. What is the composition of the lithosphere? The lithosphere is composed of the upper mantle, the ocean crust, and the continental crust. Plate tectonic theory is the most important concept in modern geology. Plate tectonic theory states that the Earth's surface is composed of lithospheric plates that float in top of the asthenosphere. The word float means to move near a surface of liquid without sinking. Recall that the lithosphere is a rigid, semi-solid layer of the molten rock above the asthenosphere. The asthenosphere is mainly viscous and molten rocks located below the lithosphere. Rigid means that it has solid properties and is unable to bend. A good example is a chair, or a table, or a pencil. They have rigid properties. Recall that viscous is a property of viscosity, and viscosity is the resistance of a fluid to flow. A good example is honey or lava. In the surface, they resist and struggle to flow. Evidence of the tectonic plate theory can be attributed to one major mechanism in theory, known as continental drift. Let's quickly take a look of a quick history of the tectonic plate theory and how the mechanism of continental drift contributed to the tectonic plate theory. In 1906, a young scientist in Germany, Alfred Wegener, became fascinated by how the shape of the continent seemed to have a lifelong pursuit of supporting evidence for what became known as the theory of continental drift. Alfred Wegener hypothesized that the continents once formed part of a single landmass, which he named Pangaea. According to Wegener, all continents used to be one single continent, as you can observe in the image to the right. And about 200 million years ago, Pangaea began breaking up into smaller continents, drifting to its present location. Continental drift describes that the continents were once a single continent and then moved. As you can observe in the image to the left, A continent were once one single continent, and then they began to drift slowly away from each other. There are 7 continents on the planet: the Antarctica, North America, South America, Africa, Europe, Asia, and Australia. All continents were once part of one single continent. Let's put into practice what we have learned. Pause the video right now and answer the following 4 questions. What is the plate tectonic theory? Plate tectonic theory states that the Earth's surface is composed of lithospheric plates that float in top of the asthenosphere. What evidence support the tectonic plate theory? The continental drift. Who is Alfred Wegener? Alfred Wegener is a geologist who hypothesized the continental drift theory. What is the continental drift theory? The continental drift theory states that the continent were once a single continent and then moved. Now that we have learned that plate tectonic theory states that the Earth's surface is composed of lithospheric plates that float in top of the asthenosphere, what are plate tectonic, which holds a different definition from the plate tectonic theory? Plate tectonics is the study of the movements of the lithospheric plates and the consequences of that movement. Tectonic plate movements. There are 3 types of plate boundaries, which are convergent plate, divergent plate, and transfer plate, as you can observe in the image to the left. You will find a divergent plate. This plate has a divergent boundary. Boundary means that there is a line of division or a line of borders. The line of division and the divergent plates move away from each other. Next, you have a convergent plate, and the line of division move towards each other. And then in the bottom, you have a transform plate, where the boundary or line of division slides past each other. Next, we will move on learning about the 3 types of tectonic plate boundaries, starting with divergent plate boundaries. Divergent plate boundary occurs when the plates are separating and moving away from each other. There are 2 types of divergent plate boundary occurring in the planet, which are oceanic divergent boundaries, continental divergent boundaries. Diverge means to go on different directions or move away from each other. Next, we will learn about these 2 types of divergent plate boundaries. The ocean floor is constantly being pushed apart by oceanic divergent plate boundaries. Oceanic divergent boundaries are divergent plate boundaries that occurred only in the ocean. The figure to the left shows 2 arrows in the asthenosphere layer of the upper mantle. These arrows point to magma. As magma rises, the lithospheric plates begin to move away from each other. The ocean floor begins to open and magma erupts, forming mid-ocean ridges. Mid-ocean ridges are continuous chambers of volcanic mountains formed by oceanic divergent plates deep in the oceans. A good example of oceanic divergent plate boundaries is the Mid-Atlantic Ridge, which is very visible from satellite. This mid-ocean ridge expands all the way from the South Pole in South America, all the way up to North America, Europe, and the North Pole. Next, we have another type, which is continental divergent boundaries. Continental divergent boundaries are divergent plates boundaries that occurs only in continents or lands. The same principle of forces and motions in oceanic divergent plate boundaries also applies to continental divergent plate boundaries. The only difference is that continental divergent plate boundaries occur in continents. As magma rises, the lithospheric plate begins to move away from each other, as you can observe in the image to the left. The continental floor then begins to open and magma erupts, forming rift valleys. In oceanic divergent plate boundaries, mid-ocean ridges are formed, and in continental divergent plate boundaries, rift valleys are formed instead of mid-ocean ridges. A good example of continental divergent boundaries can be found in Africa. Continental are often visible, and a good example are the boundaries found in Eastern Africa, from the country of Eritrea to Ethiopia, Kenya, Tanzania, Rwanda, and Sudan. These boundaries are separating and moving away the eastern part of Kenya, Ethiopia, Tanzania, and Somalia from the rest of Africa by 1 to 2 feet every 1,000 years. Now that we were able to successfully learn about divergent plates, next we will learn about convergent plate boundaries. Convergent plate boundaries occurs when the plates are moving towards and collide with each other. There are three types of boundary collisions: oceanic convergent plate boundaries, continental convergent plate boundaries, and ocean continental convergent plate boundaries. We will study each of these three types of convergent plate boundaries collisions, starting with oceanic convergent plate boundaries. Oceanic convergent plate boundaries are convergent plate that occurs only in the oceans. These plates are forced together by the spreading of the ocean floor. Tremendous forces are created as the plates collide. Oceanic convergent plates create volcanic islands, and they can create the strongest earthquakes in Earth. As you can observe in this image, the lithospheric plates moving downwards is subducting into the asthenosphere. This region where the subducting plate, which is the lithosphere, subducts into the asthenosphere is called a subduction zone. A good example of oceanic convergent plate boundaries can be found in the Pacific Ocean. The Ring of Fire is one of the most famous subduction zones areas found in the Pacific Ocean, taking place all the way from South America, North America, Asia, Australia. Earthquakes in these regions are very devastating. They can be strong and create huge tsunamis. Next, another type is continental convergent plate boundaries. Continental convergent plate boundaries are convergent plates that occur only in continents. The forces of continental convergent plates can form mountain ranges. As you can observe in the image to the left, the pressure formed by the subducting continental crust into the other continental crust form a huge dome of mountain ranges that can stretch all the way from many miles away. A good example of mountain ranges can be found in the Himalayas, in the Asian continent, which was formed when India collided with the Asian continent. The forces of continental plate boundaries can form huge mountain ranges. The third type of convergent plate boundary is oceanic continental convergent plate boundaries. Oceanic continental convergent plate boundaries are convergent plates that occur between oceanic plates and continental plates. The effects are often similar to oceanic convergent plates, but the only difference between the materials involved causes the oceanic plate to subduct under the continental plate. As you can observe in both images, oceanic continental convergent plate boundaries often creates a trench. A trench is a deep line in the sea found next to the continents, and they can be so deep and dangerous. Now that we were able to successfully learn about convergent plate boundaries, next we will learn about transform plate boundaries. Transform plate boundary are plates that move past each other. Transform plates can be found in any location where plates exist in conjunction or connected with convergent and divergent plates. They produce transform faults, which are fracture zones, as you can observe in the image to the bottom. We have a good example of the San Andreas Fault, found in the state of California. Transform plates can produce extreme earthquakes in areas near the fault line. Let's put into practice what we have learned today. Pause the video right now and answer the following 5 questions.
Please hang up and try again.